Okay. Hi, I'm Sanya. Me and my partner Nairit Chatterjee worked on nighttime traffic monitoring and vehicle differentiation system for P Club UIT's AISOC, the AI Summer of Code 2027. So, the problem statement was that we had to curate an algorithm which would be able to accurately and efficiently detect vehicles and read their number plates, especially during the night time. So the main objectives of our project were, first of all, curating a data set for both vehicle detection and number plate detection, especially during night time. The second sub problem or objective was to curate a specific model, object detection model, especially for vehicles and number plates. And thirdly, it was building a whole algorithm or a software which would be capable of performing the task of vehicle detection and number plate detection efficiently and accurately during the night time. So starting off with the data set, we used a subset of the BDD100K dataset. This is a dataset which was built by Berkeley, and it has some 100,000 videos of driving basically, and we used a subset which included only the nighttime dataset. This is the link from where we downloaded the dataset. For example, you can see that there are multiple vehicles, bikes, rider, a person, cars, and all of them have been annotated in the YOLO V8 format. We will come to YOLO V8 in the later part of the video. So we used the subset which included around 3000 images and the YOLO V8 annotations. However, we could not directly use this dataset because of certain constraints. For example, in many images, the number plates were not clear, or there was too much glare from the headlights of the cars or from the street lights or the traffic lights. So in order to improve the quality of our dataset, we implemented various pre-processing steps. First of all, we implemented some very basic brightness and contrast adjustments to all the images, and after that we worked incessantly on the glare suppression. The glare here refers to the light which is coming from the headlights or the traffic lights. As you can see, it is very difficult to detect the number plate of a vehicle, especially due to the glare from the headlights. So for the same, we implemented many such algorithms. First of all, we implemented saturated region detection, PSF detection, and many more to detect and create a mask which can tell in which region the glare is present and in which region is not. So these are the various ways. The bloom artifact detection worked the best for creating a mask of the glare. However, after identifying the mask, we could not accurately suppress the glare, and that is why we could not actually include this in our data pre-processing, but these are the results of our tries. We also used Clahe and deep learning methods. After that, we came to YOLO. Okay, so no data, because our dataset only had around 3000 images, we needed to increase the dataset, for which we implemented certain augmentation steps. What were these augmentation steps? First of all, we clipped the images horizontally, we increased the lightening, then we induced some blur and some noise in order to mimic what happens to the cameras which are capturing the vehicles at night time during winters or during rainy seasons when there is too much fog. So after the augmentation steps, we finally came to the vehicle detection models. YOLO V8 stands for You Only Look Once, which is a specific object detection model, and YOLO V8 refers to the version 8 of YOLO. So, first of all, we implemented fine-tuning YOLO V8 on our custom dataset of vehicles, which we had curated after data preprocessing and augmentation. However, the results were not satisfactory enough, for which we needed to create a new model which could detect them better. So here is the architecture of the specific model, and this did give better results, thankfully. So after the vehicle detection part was done, we moved forward to number plate detection. And for number plate detection, we used this open source dataset from RoboFlow, which had around 10,000 images of number plates. As you can see, these are the number plates. And our model, which we had built for vehicle detection, worked well enough for number plate detection as well. And these are the results of it. It accurately detects the boundary of the number plate, after which we implemented the OCR, optical character recognition, for reading the number plate. So these are the results, and the whole this is the whole code of our project, which is available on GitHub. It has been forked from PClub UIET's AISOC repository, and you can check it out. The link for our repository is in the description, along with which it also includes the link to our processed dataset. And in case you want to go and build your own with the raw dataset, then from the RoboFlow one, you can use that too. It is also in the description. So all in all, we were able to create an software which can successfully detect vehicles during nighttime, classify them between car, bikes, motorbikes, etc. with a probability, and also detect the number plates. Thank you.